What I'm going to do now is show you what it looks like when you start the experiment. So I'm going to fire up the application. I'm going to share my screen so you can see that. So this is what it looks like when the screen is being shared. This is the application screen. And so I'll make believe we're doing a practice session here. You click on it. What it's doing is now it's telling you it's going to do calibration. So this will go on for 10 minutes. I'm going to just speed ahead because the screen will just look like this for 10 minutes and showing you the optical signal inside the box. The vertical scale is, it doesn't really matter what it is. It's a ratio of two different beams of light inside there. Most of the time, it'll be pretty stable like this. You're looking at extremely high resolution, which is like why it looks very noisy. If you were able to pull back a little bit, you'd see it's actually quite stable. And sometimes you'll see that there are oscillations. You might see the oscillations more clearly when this goes on for many minutes. And that's because the laser gets warm as it goes longer. And so the box takes about 10 minutes to settle down and get a stable signal. One thing I'll show you while we're watching the screen there is that the light has turned red, which indicates that the system is in calibration mode. Also notice that the signal itself changed pretty dramatically when I picked up the box to show you this. This is one of the reasons why when you do this experiment, not only should the general environment be pretty quiet, but do not touch the box. The optics are very, very sensitive. I have ways of telling. There are sensors in the box that will tell me that the light change here was not due to your mind, but due to the fact that the position of the box, the vibrations, electromagnetics, magnetics, all kinds of things may have changed, and there are sensors in there that will tell me that. So if I see this kind of a signal when the experiment is running, I'll know probably not to use this session because the box was moved. So when you do actual experimental sessions, be sure to maintain a very stable surface. Do not move the box at all. When the calibration finishes, you go into this session here, please relax. So there's no feedback on the box. There's just a blue light showing. And here you're withdrawing your mind and thinking about something else. This lasts for 30 seconds. When it switches over, you'll hear a voice that says, please focus your attention. And three things are happening. Your task is to make the line move up. Try to mentally move the line up. That means that the effect that we're hoping to see is actually happening. At the same time, the box will show a green color. It can become greener and brighter the more that the line moves up. And there's also a droning tone that's playing. The more the line moves up, the louder the droning will be. And then we switch back into the relaxed condition. So this kind of switching back and forth between relaxing for 30 seconds, attending for 30 seconds. The relaxing 30 seconds seems long, but it really is 30 seconds. The attending 30 seconds often seems short because you're actually engaged in trying to do something. So given the multiple forms of feedback, the graph, the sound, the LED light, use whatever you wish. It doesn't really matter. You could use all three at the same time. I prefer to actually do this kind of a test in a dark room, and then the LED light is quite bright. I also made a little plastic hat that you can put on top of the LED to block any extraneous light that may be around, and that would help brighten the LED light itself. And you might wish to use that. So this is all the experiment looks like as it's going back and forth. When it gets to the very end, it'll tell you that it saved the data and sent it to me.